Our next talk will be by Leonardo Surdo. Leonardo, if you could go ahead and share your slides in preparation for your talk.
Thank you, Andrew. Good morning and good afternoon, everyone. So let me select my screen. I hope you can see my screen right.
Yes, thank you. Well, it's, if you swap, yeah, there we go. Perfect. Okay, Leonardo, please take it away.
All right, so just, there you go. So yes, so my name is Leonardo Surdo, and I work for the Human Spaceflight and Robotic Exploration Program Directorate at the European Space Agency, and this presentation will be about the European Space Agency's contributions into radiation research at Gateway, and contributions to this presentation are from other colleagues from the European Space Agency, as you read there, as well as from the Japanese Aerospace Exploration Agency, given JAXA is providing and contributing instruments to the payloads that we are currently pursuing for the Gateway station. So this slide is just to give an overview of what the European Space Agency's human spaceflight and robotic exploration mission roadmaps looks like. So at the moment you can see that we are in phase 0, where we are continuing research and testing on board the International Space Station in the low Earth orbit, and we are going to move as of this decade to the lunar vicinity, and in this we are currently collaborating with NASA, CSA and JAXA into assembling the Gateway lunar station. And then that marks phase 1, and then from phase 1 we will build up also capabilities for entering into phase 2. I don't know why it's moving on without any clicking, but phase 2, which entails the robotic exploration of Mars in preparation of future human space exploration missions. So we decided to contribute to the so-called early phase of Gateway utilization with radiation payloads. Why? Because we are expanding the human presence beyond the low Earth orbit, and the Gateway is going to be there. And so still we want to address some of the risks that human spaceflight has when moving beyond the low Earth orbit, and radiation, of course, is one of the inevitable and dominant features which are relevant to not only crew health and safety, but also overall to mission success, if we also consider the impacts that radiation has also on the electronics. Of course, the energies and spectra of ionizing radiation in the deep space environment is different from what we are currently experiencing on board the ISS with the low Earth orbit space radiation environment. So we are keen into better into mapping the radiation environment at Gateway Station destination, and so be able to compare also what kind of radiation environments we will find there with respect to what we are currently measuring with also other space missions. So ESA has decided to contribute to radiation research in order to determine the radiation environment outside of Earth's magnetosphere, compare measurements at different locations and times with the same instrumentations in order to achieve cross-calibration and accurate spectral reconstruction. And all this and all the data that we will be collecting from the Gateway payloads will enable us to determine the health risks for astronauts and validate and improve existing Van radiation belt models, and I will explain why. So all this is because ESA wants to prepare for and ensure safe astronauts mission. And in this sense, we want to improve space weather forecast and nowcasting capabilities, as well as we want to understand countermeasures against space radiation through shielding. As I was saying, ESA has a long heritage of radiation research using different platforms. On the ISS, we are using currently different platforms. For example, the DOSIS 3D experiment that is mapping radiation inside the Columbus module. And we also performed experiments using the Matryoshka payload, looking at radiation dose absorbed by a mannequin with analog of human tissues. Also, we are running a ground-based facility program for radiation called the IBER program, which stands for Investigation into the Biological Effects of Radiation. And then we are running other ESA missions with radiation instruments, for example, the ERSA, Joby-B, Planck, Integral, Rosetta, and other future Earth orbiting and interplanetary missions where we are focused to measure radiations at those different space locations. So for the early phase of gateway utilization, the ESA research is mainly represented by two payloads. These are the ERSA External Radiation Sensor Array and the IDA Internal Dosimeter Array. These two payloads are planned to be launched with the first two elements of the gateway, which are the power and propulsion element, also known as PPE, and the Halo habitation module, which will be flown in 2024 as currently scheduled. So for the European Radiation Sensor Array, this is an overview of what this payload will consist of. As you can see, there are several science instruments on one single platform, which will be externally mounted on the power and propulsion element. And these instruments consist of two ESA European active dosimeter boards, SRAM, ICAR-NG, and GRM. We will also have two Medipix units and two magnetometers.
2 minutes.
The science objectives of the ERSA payload are to measure long-term the radiation environment outside and inside the Earth's magnetosphere, explore concepts for real-time radiation alerts, operational space weather services, magnetosphere radiation belt modeling. The ultimate goal is to support the generation of models for near real-time radiation warning on board gateway for crew safety and for modeling inputs into shielding propagation and radiobiological effective dose equivalent calculations in order to better prepare or best prepare for future human exploration missions beyond the moon and forward to Mars. I was mentioning that not only we will map the radiation environment at gateway destination in the gateway lunar orbit, but also we will be able to measure the radiation environment across the Van Allen belts, because the power and propulsion element and the Halo module in which the ERSA payload will be flying will have a low transit across the Van Allen radiation belt, so there will be an opportunity to improve radiation belt modeling with measurements performed also during this transit. Internal dosimeter array instead is a payload which instead will be located within the Halo module, the habitation module of the gateway, and will consist of one European active dosimeter mobile unit, one treacle detector unit, one Medipix, and then one pedals and one D-space dosimeters from our colleagues at JAXA. As you can see, most of them, they are active dosimeters, but the pedals, which is a passive dosimeter provided by the colleagues at JAXA as an internal control to the active dosimeters during their mission. All these instruments will be grouped together into one payload called IDA, and they will all be controlled by a central electronic unit, which will provide structural power and data interface between the instruments and the gateway. The IDA science objectives are to improve radiation physics models for cancer, radiation-induced aging, as well as cardiovascular and central nervous system effects, supporting crew risk assessment for deep space exploration missions. The data coming from IDA will help refine radiation transport models, evaluate radiation shielding and spallation product generation by the gateway structure, and study radiation effects on electronics in deep space as well. Thanks to IDA and the fact that IDA also consists of instruments which are common to the ERSA external payload, we will be able to compare measurements from inside and outside of the gateway. And yeah, also with IDA, we are going to acquire data during the transit phase of the first two elements of the gateway to its final orbital destination. Even during uncrewed periods, ERSA and IDA will be able to measure radiation and downlink the data for scientific utilization by the scientific community. It's the ERSA and IDA payloads are a contribution from ESA in collaboration also with NASA, which is currently pursuing also a sister payload on the first two elements of Gateway, which is called Hermes. And together with the Hermes NASA experts and selected science teams, we are going to have complementary objectives and instrumentation shared, as well as the data. And in particular, a radiation and space weather working group with representatives from NASA, ESA, CSA, and JAXA is currently meeting already twice monthly to address joint science for these payloads, and we will extend the participation to this working group also to competed and selected the scientists for making use of the ERSA and IDA payloads. We are currently also elaborating data policies and solicitations to compete the scientific community across the across the countries of the partner agencies to the Gateway program. And what we are currently pursuing is a data policy which provides no prior access prior access rights to the data, but all the data will be freely available to all the scientific community for them to make for them to analyze to use them and analyze them. But for sure, the competent scientists who will be selected will have the capability to interact and interface with both the Gateway program and the selected teams from the Hermes NASA side. So please stay tuned. The ERSA and IDA announcement of opportunity will be released soon, tentatively towards the end of August. And what we are looking for is an international collaboration between the scientists coming from countries of the partner space agencies to the Gateway program, such that we can have a multilateral international endeavor in making use of the ERSA and IDA data from the Gateway. I think that was it from my side. Thank you for listening.
Okay, thank you, Leonardo.